Hello everyone. Hope you guys had a great Thanksgiving break. I'm sorry I'm not there today. I have a meeting that I am at during your class period. So I am going to get you through these notes through this video. These are fairly simple notes, so you should have no problem understanding the material. If you follow along and you try to understand what it is that I am saying and showing you, this should be pretty easy for you to do. So there shouldn't be anybody coming back and saying they completely did not understand this lesson at all. Everything is pretty much everything we've already done before. It's just looking at it in a different way. So exponential functions. If we look here, an exponential function is in the form y equals a times b to the x power. So now we have this x power, which is making it an exponential, okay? The a, so write this down with me, the a is the y-intercept. Okay, so the a is the y-intercept. That almost looks like a G, so let me make it a little better, the y-intercept. The b is the growth factor. So those two letters, A, the y-intercept, and B, the growth factor, are important when we are graphing and understanding the graph, okay? All right, so some other important information that you're going to need to know is we know the y-intercept on this one is 2, and the growth factor is 5. When the growth factor is greater than 1, so when b is greater than 1, this is exponential growth. So this is the growth, and we're going to talk about this again a little bit later. On this one, the growth factor is actually, or the y-intercept is negative. Since there's no number in front of it, we can assume that it's 1. So the y-intercept is going to be a -1. So when it crosses the y-axis, it's going to cross at -1. The growth factor is a half. So that is between 0 and 1. Anything between 0 and 1 is exponential decay. So if it's a fraction, it's decay. If it's greater than 1, it's growth. So if you can remember those two things, you're in good shape so far. Exponential functions increase or decrease rapidly. So when it increases, that's the growth. When it decreases rapidly, that's your decay. To determine if a function is linear or exponential, the exponential, the independent variable x, increases or decreases by a constant amount. So the x is by a constant amount. It's going to increase or decrease, which means it's going to be a plus or a minus. And the dependent variable is multiplied by a constant number. So it's going to be times some number. So we're going to take a look at what that means. We've already done linear tables, so we're just looking at the exponential tables now, and we're comparing to see which one is linear and which one's exponential. So if we look at the first one, remember we want to look at the change in x and the change in y to determine if it's linear or nonlinear. So the change in x from 0 to 1, it's going up 1, so that's plus 1. From 1 to 2 is plus 1, from 2 to 3 is plus 1. The y value from 2 to 4 is plus 2. From 4 to 6 is plus 2. From 6 to 8 is also plus 2. So since the top and the bottom, the x and the y, are both increasing by plus, then we already know that that is a linear function because we've done these before. And remember, to find the rate of change, it's the change, the change in y over the change in x. The change in y is 2, the change in x is 1, so the rate of change is 2 over 1, or just 2. So basically that's finding your slope. So nothing new, just kind of a a recall on that one, just to see what you remember. All right, the second one that we're going to look at, we know the top increases by 1 for each one, and the bottom, 4 to 8, we could say that it's plus 4, but then when we go 8 to 16, that doesn't really work so well. It's not a plus 4 again. So we know it can't be linear. So that means we have to go back and check. Does it multiply by some number to get to each of those by the same number? So 4 multiplied by 2 gives me 8. 8 times 2 is 16. 16 times 2 is 32. So I know that this has to be exponential because, like we said at the top up here, the x value is a constant value, increasing or decreasing, adding or subtracting at the exact same number, and the dependent variable y is multiplied by a constant number. So in this case, it's multiplied by 2. So my the ratio for that is times 2. So it's an exponential by 2. All right, the next one, number 3. The top is increasing by 1, and the bottom, 8 to 4 goes down 4, but then 4 to 2 only goes down 2. So I know something is up. It cannot be linear because it's not decreasing by the same number. So let me see if there's something that I can multiply this by to get these numbers. Well, if I take 8, half of 8 is 4, so I know I can multiply by a half to get to 4. 4 and 2, half of 4 is 2, so if I multiply 4 by a half, I'm going to get 2. And also the same thing, if I multiply 2 by a half, I'm going to get 1. I know you look at it like they're all divided by 2. Well, dividing by 2 is the same as multiplying by a half. And remember, when we have exponential functions, the bottom, the y values, are multiplied by something. So we can't say it's divided by 2. We have to say that it's multiplied by a half. So this is exponential by a half. All right. So that is how we figure out if they're linear or exponential given a table. Now we're going to evaluate each function for the given values of x. Nothing new. We've already done this. It's just in a different form. So if we look at this first one, y equals negative 2 times 5, and it tells me that x is 3. So wherever x is, I'm going to plug in a 3. Now I'm going to evaluate this. So y equals negative 2. We have to do the exponents first. So we have to evaluate this first. Remember, our order of operation rule says do parentheses and exponents first. So 5 to the third power, you need your handy dandy calculators. 5 times 5 times 5. That gives you 125. So then y equals negative 2 times 125 is negative 250. And that is it for finding the value of x. So you can do that for each of those. If we look at number 2, we're just going to plug it in. Y equals 3, 0.5 to the negative 2 power. Oh, we have negative 2, which is a negative exponent. And remember, we can't have any negative exponents. So what do we have to do with this? We have to flip it and make it a positive exponent. So now I have 1 over 0.5 to the second power. Well, what is 0.5 squared? So this is going to give me 3, which is 1 over 0.25. And 3 times 1 over 0.25 is the same as multiplying straight across, 3 over 0.25. And if we put that into our handy dandy calculator, we are going to get 12. And if you think about it, there's 4 quarters in a dollar, right? And we need $3. And so I need 12 quarters to make $3. So that does make sense if you think about it that way with money. Anytime you have questions, always think about numbers with money and you should be able to figure that out. All right, number 3. Y equals 1/2, 4. Since x is 4, we're going to raise it to the 4th power. Y equals 1/2. 4 to the 4th power means 4 times 4 times 4 times 4. That gives me 256 if you put it in your handy dandy calculator. So then y equals half of 256 is 128. If I go back and just look at these quickly, on this first one, the first function, y equals -2 times 5 to the x power. 5 is my growth factor, so is that going to be growth or decay? Since it's greater than 1, we're going to say that this one is growth. Number 2, since my growth factor is 0.5, it's between 0 and 1, I'm going to say this one is decay. And number 3, since my growth factor is greater than 1, it has a 4, I'm going to say that this is growth, exponential growth. Okay? All right, so now we're going to get down to the bottom where I told you we would talk about all of this again. Here is your function. This is your parent function, y equals a times b to the x. We know a is the y-intercept. Remember, that's the y-intercept. B is your growth factor. And that determines if it's exponential growth or decay. Your graphs, when b is greater than 1, this is going to represent a growth. So these are both growth. This goes increasing rapidly. This one is underneath. This one over here is above the x-axis. The graph is above the x-axis. This one is where the graph is below the x-axis. If it's below the x-axis, that means my a value had to be negative. It would have been -ab to the x power. This one is y equals ab to the x power. This has a positive a. So the only difference in the graph is when the graph is negative, or when the function's negative, the graph is going to be below the x-axis. And that's something you're going to need to remember when we talk about domain and range. If we look here, we're going to go ahead and talk about those. The domain of this function is your x values. So these are the x values. So the domain means it goes from this point, it continues in this direction going that way, and it also continues in this direction going this way, which means it's going to include all the x values because it continues and it goes on and on and on and on and on. It never stops. So if it contains all of the x values, that means our domain is going to be all real numbers. And remember, we can use that big capital R to represent all real numbers. This is what I'm expecting you to use. Everything that we do for exponential growth and decay, the domain is always going to be all real numbers, so you should not miss this part. on a test or a quiz. All real numbers domain is always all real numbers. You may see it go from negative infinity to infinity. So you may see something like that, those negative numbers. But this right here is what I'm expecting you to write. All real numbers, or the capital R representing all real numbers. Okay, the range is going to be different. So the range on this one, this first one, when the a value is positive, the range is always going to be y is greater than 0, because the graph is always above the x-axis, which y is equal to 0. So if that's the case, the range is always y greater than 0. In this case, where the graph is below the x-axis, the range is going to be y is less than 0. Two easy things to remember. If the graph is above the x-axis, it's going to be y greater than 0. If the graph is below the x-axis, it's y less than 0. And the domain is always all real numbers. So looking at this one, this is decay because the b value is between 0 and 1. So we know that is going to be some type of a fraction. If it's a fraction or a decimal that is smaller than 1, then it is going to be a decay. And when it decays, it decreases rapidly and gets close and close and close to the x-axis, but it never crosses. And the domain for this is always all real numbers. But the range for this one, since it's above the y or the x-axis, it's going to be y is greater than 0. This one, or this first one still, if we still look at this one, this is when a is positive. This one over here is when it's going to decrease rapidly going the other direction. This is when a is negative. The domain is still going to be all real numbers, just like every other problem. And now the range, since it's below, the graph is below the x-axis, the range is going to be y is less than 0. Those are the only two things you really need to remember, is what the domain and range are. Domain is always all real numbers, and the range is going to be either greater than 0 or less than 0, depending on where the graph is. All right, so let's try some graphing. And I know we're not going to do all of these because it's going to take a long time, so we're going to kind of skip through some of these and see what we can get done. I may fill some in for you just so that you have what the graphs look like when you're doing your homework. All right, so here we only have our b, which means our a is 1 because it's not showing. And so this is going to be exponential growth because it's 3, so that makes it a growth. It's greater than 1. The numbers I'm going to use, -2, -1, 0, 1, and 2. These are the numbers that we use for all of these graphs. It's always going to be -2, -1, 0, 1, and 2. That is not ever going to change unless we give you something different in particular. But if nothing is filled in, you are going to do -2, -1, 0, 1, and 2. Okay, so now we need to use our function, which is 3 to the x, and we're going to plug in the x value. So on the first one, I'm going to plug in -2. So I have 3 to the -2 power. Well, I can't have 3 to the -2 power. We just had a quiz over that. I have to flip it and make it positive because I can't have a negative exponent. So these rules are still applying here. And then what is 1 over 3 squared? It is 1 over 9. 3 to the -1 is 1 over 3. 0 is going to be 1, and I know that because My y-intercept is not here, but remember we assume that it's 1 because if there's nothing there for the a value, it's 1. If you forget, remember you could plug it in 0 for x. Anything to the 0 power is 1. So that verifies that that is 1. 3 to the first power is just 3. 3 to the second power is 9. Okay, now we can graph these on the graph, so let's take a look at it. I'm going to start with the bottom here just because those are the easier numbers, and I'm going to tell you kind of how to work your way up to the fractions and where those need to be graphed. So we're going to go with 2, 9 first, so graph that on your graph at 2, 9 is right here. 1, 3. 0, 1. All right, and then -1 and 1/3. So -1, 1/3 is just above negative, between 0 and -1, but it's just above the 0. It's not quite at a half, so it has to be a little bit less than a half. So we're going to plot that right there. Oops, I completely plotted that wrong. It should be above, right up here, sorry. And then -2 and +1/9 is going to be really close to 0, and -2 and 0. So when we are graphing these, if you notice the graphs on the other side, they're going to come down and they're going to get really, 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 really close to the x-axis, but they are never going to cross the x-axis. So you don't want to have a graph that comes down and crosses and looks like that. That is not exponential growth or decay. It will never cross the x-axis wherever it goes. Okay, so it's going to get really, really close, but it will never cross. So if I see graphs that cross the x-axis, they are going to get marked wrong. So you make them really, really close to the x-axis. They can almost be touching at some point, but they will never cross. All right, so now let's look at the domain. Domain is always all real numbers. And again, you can write it out all real numbers, or you could just use the capital R, the fancy capital R. And the range is the graph above the x-axis or below the x-axis. Since it is above the x-axis, we're going to say y is greater than 0. That means all y values greater than 0. All right, the second one, -2, let's fill in the table. -1, 0, 1, and 2 are typical numbers. Since it's a half, I know this is going to be a decay. So I know my graph is going to come down and get close to the x-axis. It's going to decrease rapidly. So we're going to plug this in. 1/2 to the -2 power. Well, that means I got to flip my numbers, which is going to be 2 over 1 squared. 2 squared is just 4. So that is going to be 4. If we do 1/2 to the -1, that means it's going to be 2 to the first power, which is 2. If you forget, 1/2 to the 0 power is always 1, and if I look up here, I didn't have any a value, so it's 1. 1/2 to the first is just 1/2, and 1/2 to the second is 1/4. So 2 squared is 4, so that's 1/4. Okay, let's graph it. -2, 4, -1, 2, 0, 1, 1 and halfway, and 2 and 1/4. So it's just going to get really, really close to the x-axis. It's going to come down and get super close, but it's never going to cross. Okay. Domain is all real numbers. And the range, since it's above the x-axis. The range is going to be y is greater than 0. Okay. When there's a number in front, okay, so when there's a number in front, that is your y-intercept. So now we see the y-intercept, it's a half. This is still my growth factor, which is 2, so I know that that's going to be exponential growth because it's greater than 1. Fill in the table, -2, -1, 0, 1, and 2. And if we multiply using -2, this is going to change to 1/2 times 1 over 4, which is 2 squared, which is 4. So this is going to give me 1/8. 1/2 times 2 to the negative first, which is 1/2 times 1/2, which is 1/4. 0, I know is a half because that's my y-intercept here at the top. 1/2, 2 to the first is just 1, because 1/2 times 2 is 1. And 1/2 times 2 squared is 4, so 1/2 of 4 is 2. Graph them. I'm going to start with 2, 2, 1, 1, 0 and a half, -1 and 1/4, and then -2 and 1/8. It's getting really, really close to that x-axis. We're going to come down, and it's going to get close. It's never going to cross. And there we have it, our exponential growth. Domain is always all real numbers. Range, since it's above, it's going to be y is greater than 0. Okay, we got through 3 of those. We have 3 more to go. We'll try to get through these ones a little bit quicker. They're a little bit different because now these have a negative value in front of our growth factor, which is a negative y-intercept, which is going to put the graph underneath the x-axis, so our range is going to change on these ones. That's the only difference, is the range is going to change and the way we graph it. So if we look at the first one, we can assume that this is -1 inside of there because it's just a -1. So our growth factor is still greater than 1, so this is going to be a growth, exponential growth. -2, oops, -1, 0, 1, and 2, we're still going to be using those. -1, 4 to the -2, which means we're going to flip it. It's going to be -1 times 1 over 4 squared. 1 over 4 squared is 1 over 16. So this is going to be -1 over 16. If we have -1 times 4 to the -1 power, we're going to flip it, and it's going to be -1 times 1/4, which is -1/4. Zero is -1. I know that because my y-intercept is this one right here. -1, 4 to the first power. 4 to the first power is just 4, so -1 times 4 is -4. -1, 4 times 4 squared. 4 squared is 16. So -1 times 16 is -16. We can graph those. So I'm going to start with 2 and -16. Again, you could start wherever you like. I just like to start with the numbers that I'm more familiar with. So 2, and I'm going to go down this time to -16. 1, -4. 0, -1. -1 and 1/4, so it's going to be just below that. And then the -1/16 is really, really, really small, so that's going to be so close to that x-axis. So now we can go close, show the graph. It's going to be really close, but it's never going to cross. The domain is all real. And the range, since it's under the x-axis, it's below the x-axis, it's going to be y is less than 0. That's the only change, is when the y-intercept is negative, the range is going to be y is less than 0, and the graph is going to be underneath the x-axis. All right. This one, -3 is the y-intercept. 2 is going to tell me that this is exponential growth. -2, -1, 0, 1, and 2. I'm going to give you the values for these. That way we can just look at the graph. You can practice and see if you can get those answers. Okay, so you can try them out and see if you know how to get to them. That's going to help you practice. You will have practice in your homework too, so hopefully you'll be able to get to those. So -3/4 and -2, we can graph these. So I'm going to start with 2, -12, which is here. 1, -6. 0, -3. -1 and -3/2. Remember, -3/2 is a -1.5. So I know where to graph that on the graph. -1 and -1.5 is about right here. And then 3/4. -2 and 3/4 is just a little bit more than a half. So now we can draw our graph. It goes really, really close. Okay, domain is all real numbers. Range, y is less than 0 because the graph is below the x-axis. And that is it. All right, the last one. Two is my y-intercept. 1/3 is my growth factor, and since it is a fraction, I know that this is going to be decay. So my graph is going to decrease rapidly. My numbers, -2, -1, 0, 1, and 2. And I'm going to give you the numbers just for time's sake. -2 is 18, -1 is 6. This goes to 2. This is 2/3, and this is 2/9. All right, we're going to graph it. So -2 and 18 is all the way up here. -1 and 6. 0, 2. 1 and 2/3, which is between 0 and 1, but not quite at 1. And 2 and 2/9 is, or 2/9 is going to be really close to the x-axis. So it's going to come down and get really close, but it's not going to cross. Domain is all real numbers, and range, since it is positive y-intercept, the 2 is positive, that means the graph is above the x-axis, which is going to be y is greater than 0. There you have it. how to graph these. They should not be hard. We already know exponent rules, so that's the biggest thing, is following the exponent rules when we're doing negative exponents. And then just graphing them the right way and looking back to see if they make sense. So compared to where your y-intercept is and what, if it's growth or decay, you should be able to match those graphs with the information that I have given you. All right, so your homework, you have a worksheet that you are going to do, and it has about 6 graphs to practice and some of the other things, tables, and evaluating a function on it. So I will see you guys on Thursday. Have a great day, and I hope you enjoyed this wonderful lesson.